Now I'll talk about Kubernetes DaemonSet. So DaemonSet is something like a pod. So at the end of the day, it's a pod, right? But it's a pod which runs on every node you create. So if the moment you create a new node, this pod will go ahead and run there. So even if you, let's say, are not deploying any pod, but this pod will be there, right? So it's sort of like a utility function, sort of like an observer which stays. It's like an agent, right? So if you have, let's say, you are collecting the log information from those individual nodes, you basically build up a pod and then pick those logs from the operating system and push it to your central log repository. Maybe that could be one of the purposes of having that kind of thing. So if you start with your Kubernetes cluster, let's say 3 node cluster, and then if tomorrow you grow that into 10 nodes, then what happens is daemon set will be available in all the 7 newly created nodes and have this deployed over there. So you will find it quite convenient. So you create once and it basically will be deployed over there automatically for you. So whenever you create a new node, join it to the cluster, it should have all the essential component for operating pod. That's what daemon set is. It also are the garbage collected when the node leaves the cluster. So which means that if you remove the node from the cluster due to some reason, it'll be garbage collected. It'll be cleaned up from those nodes. So that's part of the life cycle. Now, Kubernetes daemon set is basically, if you think about 2 Kubernetes node have daemon set pod running on them, then you can actually also run your own pod behind the scenes. So what happens, let's say, when you have any problem in your pod number 1, the daemon set can also pick it up and then send the log information to the backend log. And using a dashboard, you'll be able to really read there's a problem here. So all this custom alert or dashboard mechanism can be configured using this daemon set pod. The typical use case of the daemon set, it basically daemon for cluster storage on each node. So it keeps checking on the available space, etc. Right? It runs a daemon for log collection on each node. So log collection is important because that's how you understand the health of your node. It run a daemon for node monitoring on each node. So you need to monitor like what is the kind of current status, how many pods are running there, how much space is left, do I need a new node or not, how many are queue in my scheduler, all these things. Based on that, Kubernetes takes a decision. Now, to create a daemon set, you can use the YAML file, which basically will have all the information. In fact, there is a reference here in the link. You can go and check it out. In the daemon set documentation, official documentation, there is a YAML file there. You can copy it and modify and run it in your own Kubernetes cluster to be able to do that. You can also directly take that controller daemon set YAML URL from this GitHub and then apply it directly. So it will be as is. But if you need to modify, you can always copy the YAML, create your own YAML file by pasting it and then modifying related to that. So let's see a demo about Kubernetes daemon set. Now, as you all know, the Kubernetes daemon set is nothing but a pod, but that pod will run on every node in the cluster. So how do you do that? So let's see a couple of the daemon sets which are already available. So if you run this kubectl command with an alias k and then say get pod, and if you say all namespaces, you see a couple of them are running inside kube system. Now I have got 2 nodes here. Okay, so to show you that, We have two nodes. Okay, node 1, node 2. All right. And then if I run this all and then say whoa, wide, it will tell you about which node each of these things are. So you see here, this is the node 2, this is the node 1. Okay. And this is something like a daemon set. Okay. And this is running in both the nodes. That is Kubernetes network, the KubeNet, and it comes with some random number to have multiple pods running. Now, similar to this, if we need to, let's say, deploy a daemon set and we deploy it, and after we deploy the daemon set, we go ahead and deploy another node or add another node to the cluster. What happens? The Kubernetes kickstarts and it installs that daemon set in the newly created node. So it ensures that all the node has at least one daemon set pod installed in that node. So let's see that experience. So if you come over here and then say cat daemon set, and that's the YAML file which we will be using to deploy. Now what we are deploying is a Fluent D Elastic Search, and it is nothing but a daemon set, but inside the daemon set, you have the pod specification, which has a container, and then inside the container, it also talks about the image, resource limitation of that image, volume details, all these things you can see over here. Now, if we need to run this, so we just simply say that a apply -f daemon set. Now it is created. Now, if we run the previously ran the command to see what all pods got created, I'll see that the daemon set is created in both the nodes. This is the node number 1 and this is the node number 2. Now, just in case, if I go ahead and delete this pod, this is gone. You'll find immediately another instance of the daemon set will be up and running in the same node. So it ensures that node has the daemon set always up and running, right? So this is what it essentially means, is that the daemon set is kind of should be available in all the nodes all the time. Now let me try removing that by giving the namespace information. It should be deleted, and as soon as it is deleted, we run this, you see that another new instance, that's PLJC2, has come up. Earlier it was D5BD9, GH8QG, and now it is this one. This remains the same. You can see they are there, but this is newly created, and it is just a 3-second older pod, which means that because I deleted one forcefully, another gets created. So let's see if I delete the G5. So let me put that G5 BD9. Now once this is deleted, then you will see newly created daemon set up and running. So you can see that there is another L2. It's in the minikube node. Okay, so that's how the daemon set ensures that all the newly added node in the cluster has that pod available.